So in the previous tutorial we have covered how we can migrate the save game system to your own project, and now let's see some of the internal implementation related details with respect to save game system, right? So you can get a better understanding about how our save game system works. So as I mentioned before, there are several core components at the save game system. One thing is that if you go to these maps and modes, here you can see that BP save game system game mode is there, and this game mode basically holds some of the core components of the save game system, right? The first thing is save game system GS, which is the game state component of the save game system, and these are some of the pretty much generic stuffs. So player controller class is there, as well as HUD controller, as well as the player pawn. Okay? So first let's go to this BP save game system GS, which is our game state controller, and here we have added this actor component, BBC save game system GS. So you can see that actor component under the components folder, and here is that actor, right? So let's open that up, and now you can see that there is only one function called or event called start, right? And this is the function that is going to start to lift your game, right? So basically it has several steps. So at the very first step, when the loading process has been started, it will show a loading screen, and then the mandatory initializations has been done. For example, let's say the HUD should be created and the relevant HUD components should be initialized, right? So this is the place that happen those initializations. So under the create HUD, you can see that basically it's create WB HUD, which is a widget blueprint, and it add to the viewport, and after that it will broadcast set of values to this specific HUD instance to be initialized. So if you go to that broadcast values function, so here you can see that we have added set of event dispatchers, because usually in order to handle some efficient way of UI updates, we are using these event dispatchers. So basically we are initializing the health, armor and money related metadata at your HUD level. Okay, so that's the second step, and then the heavy game state lifting will be started based on the saved data. So first it will wait until this minimum loading grace period finishes, because maybe based on the performance of your PC, these states will completed in very fast manner, but in order to keep a consistent state of the loading process, it is better to have some sort of a grace period, even if your loading process is extremely fast, right? So for example, let's say our grace period is 1 second, right? So we can ensure that our game state is loading in a graceful manner, right? Not like some instantaneous manner. But this is not mandatory. This is just for the sake of the visualization of the loading process. Otherwise, the loading screen will be instantaneously appeared and displayed because of your computer is extremely fast, right? But for the lower end computers and lower end GPUs, maybe the loading screen will stay for a while because it will take some time to process, right? But in either scenarios, in order to have a consistent user experience, it is recommended to have some sort of a minimum loading level grace period, right? So maybe you can increase this value or decrease this value based on your need. Okay, so that's the goal of having this minimum loading grace period, and you can configure that value under that setup category, right? And then it will get for a specific loading sequence type. So here maybe you are loading your game at the very first time, so it will go under default category, or maybe you are simply clicking the continue button and again it's a default loading type. But let's say if you are loading through a specific save game slot, then that's a custom mode of game state lifting, right? So here we capture that specific type, and based on that specific type we are performing the loading of the game. And let's say if it is a default thing, it will get the latest save slot that is exist on your game saves, right? Because that's the most obvious scenario. You are ought to be start from the latest saved instance of your game, right? So we get the latest save slot and we start the manual loading, right? Or let's say if you don't have a latest save slot, which means like let's say you are starting your game at the very first time, so obviously there are no save slots that has been created yet. So it will first create a auto save slot and then it will start auto loading, right? Okay, so that's the default state lifting. And the custom state lifting, we simply get that specific save slot, right? Because now we are start loading from a save slot onwards, right? Without using the default sequence. So that specific save slot will be searched, and if it is found, we can start the manual loading, right? Okay, so that's that manual loading process. And if we go to this manual loading instance, this is what happens underline, right? And even if you go to this auto loading instance, at the end it is pointed to this load previous game instance. So under this manual load as well, we are responsible for loading that previous game, right? The only difference is that we are start loading from two different slots. Okay, so now we are starting the manual load, which means a specific save slot onwards. So that save slot name will be there, and we get that specific save slot, and if it is found, we start the loading process. And if it is not found, we can simply print a debug message. But this is for the development purposes only, right? Because at the shipping product, we shouldn't be able to print these sort of debugs, right? But at the development level, in order to have a sort of a guide for the developer, here we have added some debug pointers as well. Okay, so let's go inside this load previous game function, and this function is actually doing a whole lot of stuff. Basically, it again get the save slot and it start the loading of the game from that specific save slot, right? So here we are taking this comprehensive save data structure and save it as a local instance, and we'll see actually what this data structure means. And based on that specific data structure, it performs all the necessary world state savings and mission reinitialization of mission state saves and reinstantiation of building saves, likewise property acquisitions and player states, as well as the player statistics, right? So these are some of the heavy lifting of your game based on this specific data structure, right? So let's see what this data structure is all about. So here you can see that it is under the name of S comprehensive save data. So you can simply go to the data, structs, saves and base, and here we have this S comprehensive save data structure. So here basically it's a collection of data structures that need to be saved, right? For example, if you need to save the pickup items state, we have a separate structure called spickup_item, and since the player can equip multiple different pickup items, it is saved as an array, right? So for instance, we can go and check out that structure, which is spickup_item save. So simply we are saving what's the class of that picked item and what's its transform, right? Because these are the only two states that we are required for now to save those pickup items, right? And based on those saves, we can initialize the states of the pickup items. And likewise, the S comprehensive save data structure is holding each and every individual such data structure. Right? So based on your needs, actually you can maybe add more data structures over here. Maybe let's say some enemy state saves, or maybe I don't know, maybe some level state saves, something like that. Right? Or you can actually improve the struct values of these existing data structures as well. Right? And that comprehensive save data structure will be used to construct our save game slot. Right? And underline the save game slot, here you can go to the saves and the SV save game. Here you can see that comprehensive save data structure is there, right? Because that's the data structure which holds all the necessary state data of your game, right? And this general save data is simply a like generic meta information that you need to save based on your requirements, right? Maybe like, let's say the default level names, or maybe is it a new game, or is it a continuation of the existing level, something like that. Okay, but the core data or core metadata of your game will be stored at this comprehensive save data structure. Okay, and then we can go back to that PPC save game state actor component. So this is that specific data structure, right? Okay, so now we have the data structure, and based on that specific data structure we can start reinitialization of the game, right? So for example, if I simply show you this world state reinitialization, here basically we get that specific data structure, and we get the world state data structure, and we pass it to the reinitialization data day night cycle specific function of that reinitialization happen, right? And we pass that world state data to it, so that function can read that world state and start the lifting of the world state, right? So for instance, this function is responsible for reinitializing the day night cycle of your world level, right? So simply it will take these values and will start the day night cycle, right? Something like that. Okay, so likewise all the necessary states will be lifted over here sequential manner, right? Okay, after that we can go back, and we are here. We can go back again, and we are here, right? So this function or this state of level is consists of set of functionalities that is simply responsible for state lifting of your game, right? So go check it out, other functions as well, in order to get better understanding. But at the very high level, that's the core idea, right? Okay, then after that stage we basically finish the loading of our game, right? Because all the necessary states and actors has been reinitialized successfully. Now after waiting for that grace period again, we can simply close our loading screen, right? Because now the loading has been done successfully, so there is no point of showing the loading level again, so we can simply hide it, right? Okay, and at the final stage of the game state lifting, we are reinitializing the autosave timer as well, because as I mentioned before, we need to be able to trigger autosave based on a specific autosave delay, right? So if you check out the game instance, and here I mentioned this at the previous tutorial as well. So here basically we can mention whether we require autosave feature or not, right? So if we enable it, after a specific delay, that autosave will be triggered based on a timer, right? And that timer will be initialized over here. So basically it will get such metadata from the game instance. So we have this interface event, and then it will set this timer for this specific delay, and then this autosave function will get triggered, which is this function, right? So at the autosave, basically it will generate a unique save slot name, and it will save the game for that specific save slot instance. The save type is now autosave, right? It's not manual. And once that save is successful, it saves the entire game for that specific slot, right? So this is basically notifying the save game slot context that we are going to create a new slot, and this one is basically responsible of creating a individual save slot, right? This one is save slot context, and this one is save slot. And after both of those operations has been completed, we can simply show some notification that says a game has been saved successfully, right? Something like that. Okay, so that's the auto saving function, and we can go back, and that function will get triggered with this timer once it reached this specific autosave delay deadline, right? Okay, and that's the last stage of the loading process. So you can see that this is a very critical function of the save game system, or critical event of the save game system, and it handles all the required reinitializations of the game states, right? And ultimately this function will get triggered at where? At here, right? Because you have been added it as a blueprint actor component, but it won't get triggered at the begin play because it's not the ideal case, because you may require some custom loading features as well. That's why actually we haven't added that start feature for the begin play, but you can go and find the references. So here you can see that under the references, under the references, here the showcase map, right? At the showcase map we are starting that game state initialization, right? So basically it is at the level blueprint itself, right? So you can go to the levels, and under that default showcase map level, you can simply go to the blueprints and open level blueprint, and here this is the place we are start the game state lifting, right? But if you want, you can add this to the game state as well, but it may incur some race conditions because game state lifting is a heavy process, right? So we always recommend to state lift once the level has been loaded successfully. So if you are adding that state lifting feature in this position, it is much safer, right? Because that begin play will get triggered once the level is initialized properly, right? And then we can lift the game state here, okay? And that start function will get triggered, and all the necessary reinitializations will get happen. Okay, right? So that's the sort of in-depth visualization of the underlying architecture of the game state lifting logic of the save game system. But actually we have a lot more to cover, such as we have to cover how the UI framework works, and maybe we have to cover how the other subsystem works. So we'll cover those stuff in upcoming tutorial. And yeah, so I think this is all about it, and yeah, thank you. And if you have any questions, please forward those stuff as well, and I will try to help you as soon as possible. And yeah, thank you. See you there.